Okay, so we are going to start studying the ray model of light. In this model, we're going to think that light travels, and when it travels, it just travels in rays like this one here. So we define a light ray as a line in the direction along which energy is flowing, in which light is traveling. We know there is a wave here traveling in this direction, but we are going to simplify that by thinking that it's just a ray. Any narrow beam, such as a laser beam, is actually a bundle of many parallel light rays, and we can think of a single ray as the limiting case of a laser beam. So there's a few things that we notice that light travels through transparent material in straight lines, and the speed at which it travels is the speed of light in vacuum c divided by the index of refraction of the material. So basically, light slows down as it travels to some materials. They do not interact, they can cross each other. And so there are four things that could happen to uh, rays when they interact with materials. Imagine that we have a material one here and a material two here. This could be a, just air, and this could be a glass, and there is an interface here. So one thing that could happen is that a ray comes and gets reflected. That is one possibility. Another thing that could happen is that it gets refracted. That means it gets transmitted and the direction changes. One thing that could happen is that while traveling in this material one, it gets scattered. It changes directions suddenly. And another thing that could happen is that while traveling in the material, it gets absorbed. It just disappears. So those are the four things that could happen to light. And in the ray model of light, we are going to define objects as sources of rays. So every point in this object is a source of rays in all directions. So they originate from every point on the object, and each point sends rays in all directions. So that's how we see things, right? So for instance, this point here sends rays in all directions. In particular, it sends rays in these directions here. They get to your eye, and you get an image here in this inside your eye. So in the retina of your eye. So objects like the sun, they produce light. They are called self-luminous, and objects like this pine, they just reflect lines in all directions. And then the camera is just something that allows you to detect or see light rays. So the divergent rays from a point source are emitted in all directions. That is important. Each point in the object is a point source of light rays, and a parallel bundle of rays could be a laser beam or light from a very distant object. So this here could be just a laser beam, or could be light coming from an object that is far, far away from you. Where a point source, like this one, emits rays in all directions. So to understand uh, uh, how images are formed and this model of rays, we use ray diagrams. And this is basic. What we basically do is we draw a few rays that allows us to capture the fundamental phenomena that is happening. So rays originate from every point. However, you don't want to draw every possible ray that originate out of this object. What you do is you choose a few points, like this one and this one, and you choose a few rays coming out of those points, and that allows you to draw a ray diagram that is easy to understand. So, and then you have apertures, and for instance, here you have this little hole, and what happens here is that you can draw a ray diagram, and you only pick this point and this point, and then Out of this point, you get these rays and only one goes through, and this is this one here. Out of this point, you get rays coming in various directions, but only one is going to go through, and this goes here. And you can see you get the image here, and it's upside down. And this H and this H0 and HI, the H of the object and H of the image, they are related because you can see these triangles here are similar, so d0 divided by di have to be equal to hi divided by h0. That is a simple property of those triangles. So, and we can apply the ray model to any type of apertures. And in this case, we have an L-shaped aperture. And let's look at this question here. You have a dark screen with a small hole, and then you have a view and a screen, and then you have a light bulb here. And so what do you see here? Do you see this image A, B, or nothing? Take a minute. And you're gonna see B, the image upside down, and you can see why, because the rays are gonna travel. This one is going to end up here, and this one is going to end up here. How about this case? What do you see? Take a minute. And in this case, you see this C here. All right. Thank you.